Hi guys. It's very honored to have you all here, and I'm very I'm very happy to have you all here. So today we are gonna talk about development tools. Before diving into the details, uh, let me quickly introduce myself first. So sorry, I'm Aiden Park, and I'm a DevRel engineer from Kaia Foundation. And I've been working in crypto industry uh, since 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 2018. So at that time, I was a technical researcher, mainly focusing on layer two technologies. As you may know or might not know, at that time the dominating layer two technology was plasma, not the rollups. It's interesting, actually. So I deep dived into plasma technology plus rollups, and researched plenty of layer two technologies at the time, and also after that, I joined Hashit, which is the leading one of the leading venture capital firms in South Korea here. So I joined the some project for K-pop idol blockchain projects. So which is very interesting. So in that project, I worked as a blockchain engineer, mainly focusing on smart contract and backend side. So I've developed all the backend infrastructure and contractings. Anyway, so after that, I joined Zero Dev, which is some company, a company uh, building account abstraction solution, like including ERC 4337. So uh, in Zero Dev, I also worked as a blockchain engineer. So yeah, and now I'm working in Kaia Foundation as a DevRel engineer. Yeah, that's my first history. So yeah, let's dive into today's lesson. So yeah, so we are gonna talk about four things today. So we will cover two main smart contract development frameworks, which are Hardhat and Foundry. We will cover how to set up Hardhat and Foundry, how to install them, and how to configure them. And also with using them, we will write and compile some smart contracts. Specifically, we will build ERC20 contracts from scratch. And also we will cover how to uh, how to normalize dev security ops in Web3. As you know well, security matters, really matters in Web3 industry and specifically in Web3 development. So yeah, we will dive into that topic too. Yeah. So I think you guys already studied about the smart contract the previous lessons. So you guys might use Remix or other frameworks like Kaya Contract Wizard. But I think you guys noticed already the Web3 development is very complex. So we need to care about smart contract itself, including blockchain networks and security and blah blah blah. So tools like frameworks like Hardhat, Foundry, they simplify those development process. So they help us to write, test, and deploy the contracts, and also debugging and optimizing uh, contracts. So yeah, there are mainly actually there was some other frameworks like Truffle, but these days Hardhat and Foundry are most popular choices. Especially Foundry is more popular choices in from the seasoned developers perspective. So yeah, yeah. As I explained already, Remix ID you may use it in previous lessons. It has some issues it has a scalability issue, so it's not suitable for complex or multi-contract projects because it's basically Web IDE and web-based IDE, and it lacks advanced project management, so like dependence handling. It's hard to import other external libraries like OpenJavelin or SolidLady. Yeah. And it also has the limitations about testing. So it has best-based testing capabilities, but it's not robust frameworks like Hardhat Foundry. For example, it does not support mainnet forking test and also fuzz testing like Foundry supports. And it's very time consuming to set up the test environment manually, and also it has some limitations in terms of DevSecOps integration. So it minimally supports for CI/CD pipelines. So let's say if we want to uh, add some automated test cases whenever we commit the codes, it's impossible in a Remix because it's Web IDE, it's simple Web IDE, and also it's hard to use static analysis tools like Slider. And yeah, also there is no built-in security auditing features. So yeah, that's the limitation of the Remix ID. So we need some other robust frameworks like Hardhat and Foundry. So let's dive into Hardhat first. So Hardhat is JavaScript-based Ethereum developed environment. So basically, if you already know JavaScript, then Hardhat is very easy to run for you because all the ecosystem and the frameworks is written in JavaScript and slash TypeScript. So it provides some features like local blockchain, like you can learn your blockchain locally, like using Hardware network, and there are plenty of plugin ecosystem, like you can import either JS or OpenJavelin library using this plugin ecosystem. And there are also they also providing some detailed error messages to for testing and debugging. Yeah. So I think the Hardhead is very ideal for beginners, uh, and also large projects. And if you are very familiar with JavaScript already, Hardhead could be a very good choice. And now we will set up Hardhead. So to set up the Hardhead framework, you must first install Node.js. So it's actually recommended to use Node Version Manager MV, which is MVM, to install Node.js. But it's okay to directly install Node.js from the official Node.js website. And if you are using Mac, I expect that most of you guys are already using Mac. You can install nvm by just typing through install nvm. It's simple. And after installing Node.js, you can easily initialize your product uh, by typing in npm init. And so it's basically initialize your npm product, and also you can install the Hardhat library into that project, and then you can use this npx hardhat init command to initialize your hardhat project. So in this case, we will use TypeScript project in these lessons. I mean, in the whole bootcamp sessions. So we will create the TypeScript project here. Yes, and you can simply compile, test, and deploy by by typing in those commands like npx hardhat compile, npx hardhat test, and hardhat ignition deploy. Yeah, that's basic commands. And actually, I've already created hardhat starter, which is basically boilerplate project for you guys. So you can click this link to check it, and you can clone it or copy and paste it in your repo, and yeah, then it's good to go. Yeah. So for hardware starter, for hardware itself. So it's very important to define this hardhat.config.ts file because it all covers all the settings of hardhat, and you can basically define how hardhat projects manage settings like network, solidity version, or other account settings, and and other testing and debugging features. So as you can see, uh you can see the hardware user config. You can set the networks here and Solidity version here. And actually, in the hardware starter project, you can get all the necessary configs for development on Kaia chain. So yeah, you can just copy and paste it. And let's dive into the details in hardware project. So when you initialize the hardware project, some default contract will be generated during initialization, so which is lock.sol. It's basically simply locks funds under a specific time. So basically, in the constructor, you can provide the unlock time, and then you lock your funds, and then you can withdraw it after the unlock time passed. Yeah, that's basic contract, and you can actually delete it if you don't need it. But it's just testing and educational purpose. And so now we are going to write simple ERC20 token from scratch using Hardhat framework. So uh, mostly every developer in Web3 industry they are using external libraries to implement ERC20 tokens, like using OpenJavelin or Solidity or Soulmate or other libraries. But for the educational purpose, we are going to build ERC20 tokens from 0 to 1. So it's called my token contract. So first, let's define the state variables first. I know you guys are already familiar with ERC20 token because we already covered the ERC token standard in the previous lesson, but it might help to understand the ERC20 token standard further by building it from scratch. So first let's define the state variables here. So name and symbol is basically the name of token and the ticker symbol, for the Bitcoin example. For example, for Bitcoin, BTC is the symbol and the name is Bitcoin. And there are decimals, is decimal places the token uses. Basically, most ERC20 tokens they are using 18 for the decimals, but there are exceptions for this. For example, stable coins like USDT or USDC, they don't need actually the large number of decimals like 18. So they prefer to use 6 decimals instead of 18. That's the thing. And total supply is for storing saving storing the total number of tokens in circulation, and the owner is basically just for access control. So maybe the address that maybe owner could be the deployer or other operator address that controls the contract itself, and the balance of is basically mapping to manage the uh, balances of each address, and allowance is also it's very similar to balances, but it's like it's literally allowance approved by any other addresses. It will be used in the delegated transfers, which is very crucial to execute smart contract executions like in DeFi's. And we can define 2 events, which are transfer and approver. Transfer is basically emitted when the tokens are transferred from one another. And the approver is will be emitted when some owners approve some other addresses to spend their tokens. Yeah, that's the thing. And now we can implement constructor function first. So in the constructor function, we can initialize all the necessary variables like name, symbol, or owner. Even we can set the decimals here, or we can initialize total supply. And if we want to initialize some initially mint uh, some tokens to the operator, then we can just set the balance of a variable like this. And then we can implement a transfer function here. So it's basically transfer ERC20 tokens from one address to another address. So basically you can provide 2 address and value amount, and in the function, it's basically validates the balance of message sender. In terms of ERC20 token here, and it checks if the balance is greater or equal than the value, and we decrease the balance of message sender, and we increase it's obvious actually. We increase the uh, 2 address balance of 2 address, and then emit the transfer event. So it's very obvious, but and the other one is approve. As I mentioned earlier, is basically approving other address to spend the owner's token on their behalf. So basically, we can provide spender address and value amount here, and we can set the allowance here. Most of device previously, when the approve function is executed, the value was basically this 256 bit. The max value of uint 256 type. So to avoid further additional approval in the DeFi like DEXs or like Uniswap, but in these days it's not recommended to do that, because it could if there is some security issue, then it could drain all the funds from this contract. So it's recommended to approve only necessary amount when you use DeFi. So if you yeah, it's another topic. Anyway, if you approve your tokens token amounts like max amount in some DeFi platforms like DEXs or lending protocols, then you must be worried about you must be cautious about the security issues because it potentially it could drain your funds when the security issues happened. Anyway, let's go back to the slides. And here is this is the most important function in the ERC20 contract, uh, which is transfer from function. So it's basically transfer tokens on the original user's behalf uh, by using allowance here. So we can provide from and to address and value. So basically decrease the value, decrease the balance here and increase the balance of to address. And then we decrease the allowance of message sender, I mean from and message sender here. But you might wonder why do we need this actually? Because we already, have this transfer function here. But the thing is, uh, when you interact with other smart contracts, I think as you know well already, but let me reiterate it. Anyway, when you interact with other DeFi contracts like let's say Uniswap, then when you trigger to a swap function in the Uniswap, then the Uniswap will be the message sender in the following core traces. So you are not the message sender of that core anymore. So that's the transfer from function comes in. So it's basically it helps to transfer tokens on behalf of the original sender. In this case, maybe text.origin instead of message.sender. Yeah, anyway, without this function, we could not use other uh, DeFi contract or other whatever I mean gaming or NFT contract or yeah or something. Yeah, that's the thing. And it's there's also we need to define the access control of this contract. So when we want to mint ERC20 tokens, we don't want to let anyone to mint let anyone mint these tokens uh yeah, so we don't want to we don't want it. So we must have some access control here. So we have to define this modifier only owner. So basically if it is not if the message dot sender is not the owner, then it reverts. So in this mint function, you can set this only owner modifier to only give access to only owner here. So yeah, and you can the other important thing is you need to emit transfer event because mint basically means transfer amount from zero address to address. So yeah, that's another important thing. So if you want to query mint transactions in any ERC20 contract, then you can filter this transfer events by uh, filtering out by selecting this from address to setting this from address to zero address. Yeah, it's very trivial tip. And we can also burn our tokens. It's basically burn your tokens, so total supply will be decreased, and the balance of message.sender would be decreased too. And like what I mentioned in mint function, it's also important to note that this burn function should emit transfer event, because basically burn means transfer uh, token amounts from message.sender to zero address. So likewise, if you want to query the burn transactions in any ERC20 token contracts, then you can set the to address as zero address, and then you can query it. Yeah, yeah, that's some trivial tips, and yeah, that's it for building ERC20 token contract from scratch. And of course, you can use external libraries like OpenZeppelin or Solidity. So if you want to use OpenZeppelin library, you can just install the OpenZeppelin library with using Hardhat. Actually, in the Hardhat starter, it's already installed. It already installed the OpenZeppelin library, so you can refer to it. Anyway, in the contract code, you can import the OpenZeppelin library code like this, and then you can use it by inheriting this ERS20 contract and all number contract. All number contract is basically for access control. Yeah. So yeah, that's simple. And yeah, we covered all the basic features of Hardhat. So now we will talk about Foundry. The Foundry is a relatively new Ethereum development toolkit frameworks, and it's interestingly is very is Rust based rather than JavaScript based like Hardhat. So it provides a plenty of features like fast compilation and testing, because uh, as you might know or might not know, Rust is considered to be faster than JavaScript, so it provides very highly performant compilation and testing features. And you can test it by with our boilerplates. I mean, hardest starters and founder starter. You can compare same contract, and then you can compare those performance. And yeah, and there are some toolkits in Foundry, Forge, Cast, Unveil, and other, and there are more things. But three, the three core thing toolkits are Forge, Cast, and Unveil. The Forge is mostly used to build and test the smart contract, and the Forecast is for interacting with the blockchain. So basically, you can send your transactions, or you can you can reiterate. I mean, you can re-execute the transaction and see the stack traces by via this cast. And the Unveil is it's basically local chain like Hardhat network, Hardhat node. So when you develop I mean, when you develop smart contract in production level, you might have to use cast uh uh often, because it's very good for debugging. So there are a few tools for debugging smart contract transactions like Tandly. So Tandly is as you might know or might not know, Tandly is some tool for uh showing the stack traces of the actual smart contract transactions. So, but the cast in my from my personal experience, cast was more accurate than the Tandly. So for the production level development purpose, I would recommend to use cast for debugging. Yeah. And also it has minimal dependencies and is very Git friendly. But I don't think these are actually from their docs, but I don't think these are the advantage. I mean, the pros and advantage of Foundry because it's actually from my personal experience, it's very hard to manage the Git sub modules like in Foundry framework. So it was very not that good experience for me. So let me and I prepared some other alternatives for this. Let me cover that later. Anyway, and or there is also very important key offerings of Foundry. So we don't need to use any other languages like JavaScript in Foundry. So it's basically in you can basically use only Solidity to write contract and test contract and deploy contract. So you don't need to worry about JavaScript. So yeah, it's also very good one of the very good features. And yeah, anyway, its Foundry is ideal for performance and advanced testing. Uh, actually, sorry, I introduced Hardhat as one of the popular choices, but these days, from my experience, personal experience, and from my uh, from my peer developers. I mean, when we talk about the frameworks with my peer developers, they all recommend the Foundry instead of Hardhat. So it's basically it's more robust and fast, and it's more I think it's more for the production level development. I mean, it's more popular choice. Yeah. Anyway, we can set up Foundry now. You can first you need like installing Node.js for initializing Hardhat project. You must install Rust, like typing in this command, like this command, and then you can install Foundry like from uh executing this command, and then you can just just typing in Foundry up, and then you can initialize a new project like by force init some project name in here, Hello Foundry, and then you can if you uh if you open the Hello Foundry project, then you can see those directories. The library is for external libraries like OpenJavelin or SolidLady, and script directory is for like deploying contracts or executing some contract functions. Source directory is really means for source codes of smart contract, and test is test. Yeah. Yeah, that's the basic structure. And then you can use those basic commands to compile, test, and install external libraries and format and deploy. So in here, we can install the external libraries like Soulmate, like using forge install, blah blah blah. But it's not but it is it will install this library using Git submodules. But like what I mentioned, managing Git submodules is very painful from my perspective. So I'd recommend to use other alternative to install external libraries. So anyway, so we have a Foundry starter. You can click the link to check it, and it's basically it's another boilerplate project using Foundry framework. So for the upcoming lessons, we will stick to this Foundry starter for development. Yeah. So like the hardhat.config.ts file, Foundry.toml file is very important. Um, So in here, you can set the environment variables like RPC endpoints and either scan API keys and some dependencies. So we have sortier here. Is that's what I mentioned earlier about the managing external libraries. So it's sortier is another toolkit for managing external libraries in Foundry. So it's natively integrated into Foundry. So let me quickly talk about the background why we need Sortier instead of using Git modules for external libraries. So actually it's very like what I mentioned already. Git some modules in Foundry are not a good solution. Yeah, it's very it's I totally agree with this point. And yeah, it's very painful to manage those uh libraries and versioning. Yeah, and often I from my experience, is highly likely, it is highly likely to be broken. I mean, in terms of GitHub modules. So it was very painful to me. And npm what we did in Hardhat project, we installed the OpenJetPoint library using npm packet, not I mean npm.js, but it was built for JavaScript ecosystem, not for Solidity. So and also GitHub versioning of the Lilies is the pain point. And so not all the projects are using Recorder. Yeah, that's the thing. So we need Soldier, another package manager for Solidity projects in Foundry. So you can install Soldier by you already installed the Soldier actually, because it's natively integrated into Foundry project. So you can install the external libraries using these commands like sortier install for the standard library 1.9.7 like this, and it will create this sortier.log file. If you are JavaScript developer, you will be very familiar with this log file, because uh because you might have experience to use npm or yarn or other burn or other package managers. So it's basically the same. It saves it manages some dependencies information here, so we can properly install and manage those external libraries like Solidity. Yeah. So how to use external libraries in the source code is basically same as we did in Hardhat project. You can import Solidity that like this. And the reason why I use Solidity for this example instead of OpenJetPoint, because in most of the Foundry projects we use in the production level, we or most of developers prefer to use Solidity instead of OpenJetPoint because Solidity is written in Solidity assembly, so it's more performant and it's more optimized than OpenJPL. So mostly Solidity is used recently for production level projects. Yeah. And the last topic is the DevSecOps. So as we know well, security matters in Web3 developments. So DevSecOps means we integrate security into development process. So why security matters in Web3 development? Because we have some challenges, like contracts are immutable. So if we have bugs, then they are permanent. So uh, but if we set the contract as a upgradable contract, then we can upgrade if we if we find some bugs, then we can upgrade the contract. But anyway, the uh fundamentally, technically, the contracts are immutable. And also the high stakes. So basically uh most of the smart contracts are financial things. So there are funds at risk, and we have to securely manage those users' funds. Yeah. So to properly manage those risks, we have some practices here. So we can set some automated testing, including unit tests and integration tests. It's very basic things. It's very basic, and we could also have static analysis tool like Slider or Mithril, and also we can have some CI/CD pipelines like using GitHub Actions. Like what I mentioned, we can automate it. We can learn automated test cases whenever we commit new changes, and also for the production development, we always have to uh, get some audits before the deployment. Yeah, and it's also important to manage private keys security. So we need private keys of the operator accounts or other owner accounts to deploy and manage various smart contracts deployed on the mainnet or testnet. So there are some best practices for managing private keys security. So the number one rule is never hard code your private key. So I saw that a few of Web2 developers who are transitioning into Web3 development. I saw that they easily put the private keys in the source code. So because they they couldn't consider the importance of the private keys. Anyway, it's very dangerous to hard code the private key in the source code like hardhat.config.ts. Always cautious to put those private keys in the source code. And we can use encrypted storage uh, like AWS KMS, key management systems, and also we can back up safely, like store offline. We can use hardware wallet like Ledger, and it's also recommended to rotate keys. So you can keep generating new keys periodically for high value accounts. So yeah, and it's also recommended to use key store instead of .env file, because anyway .env file we save those private keys in plain text. In anyhow, it could be compromised when we leak the .env file. But if we use key store file, we can minimize those attack vectors. So in Foundry, you can use the key store by cast wallet import, and in Hardhat you can use it by npx Hardhat key store set. So you can see the commands here, and yeah, this is for the Hardhat. So basically you can use your key store variable like using config variable blah blah blah. Yeah, that's the thing. And there is also another way to keep the wallet, I mean the private keys security, uh is hardware wallet. I think you guys already know it, but anyway, hardware wallet is basically physical device, like a ledger or treasure, storing private keys online. So it's basically like USB, encrypted USB wallet. So when to use it? When we have high value accounts. So basically, for example, we have some DeFi protocol admins or NFT creators, uh s- an operator, some operator accounts, then it's recommended to use hardware wallet. And for the production deployments, it is always recommended to use hardware wallet, because usually the deployer account has many uh has many power to manage those contracts internally. So it's recommended to use hardware wallet. And the other case would be long-term storage of funds or keys. And you can use it by purchasing the from official vendors like Ledger. And then you can actually the Hardhat and Foundry and other existing frameworks are all already integrated those hardware wallet for plugins into their ecosystem. So you can basically use like this. And for Kaia, we support decent wallet for hardware wallets. So you can click this link to see the details if you want to use hardware wallet in your project. And the other one is multi-sig wallets. So multi-sig wallets is basically requiring multiple signatures for sending transactions. So usually for sending transaction from existing account, you can sign with your owner account address. I mean your own owner account private keys. But for the multi-sig wallets, you have to multiple signatures from or the stakeholders. I mean, or the managers. So when to use it? When you want to manage the DAO treasuries or product budgets, like basically is managed by teams, like it's recommended to use multi-sig wallets. And for the critical operation, like what I mentioned, we should upgrade contract if we have some bugs in the contract, and if we have some security issues, uh, then we have to upgrade. So in that case, we don't want to anyone can, and we don't want to let anyone upgrade those contracts. So we need to limit the access contract. So in that case, the multi-sig wallets could be the best choice here. And also, it is very good to reduce single point of value risks. So basically, if some accounts are compromised in the multi-sig wallets, it actually is okay because not all the not all the accounts of multi-sig wallets are not compromised. So yeah, and for how to use it is basically you can deploy multi-sig wallet like Gnosis Safe, but for Kaia, you can use Kaia Safe if you want to use the multi-sig wallets in your project. And and next you can configure the signers, let's say 3 or 5 signatures. So basically there would be 5 operator accounts, and then you need 3 signatures to send transactions. And like what I mentioned in hardware wallets, already the Hardhat and Foundry frameworks they already integrated these multi-sig wallets features, so you can basically use it in the frameworks. So from my experience, is I think it's always recommended to use hardware wallets, both hardware wallets and multi-sig wallets in the production project. So, for example, when I worked at Hashit, when we have to manage the smart contract operations for K-pop idol project, we have to manage some operator funds, and also some uh, some features for upgrading contracts. So in that case, basically we we use the hardware wallet. Uh, we always use the hardware wallets for all the operations, and for securely managing whole funds, we use the multi-sig wallets. So like this, if you want to launch your project uh, on mainnet, you must consider to use hardware wallet and multi-sig wallets. Yeah, that's pretty much of it today. So yeah, I think there are some questions. Uh, yeah.
Yes, I am back, everyone. Hello. Yeah, so if there are any questions for Eden, you can either put them in the chat, or if you are brave enough, which we have had some questions before, you can raise your hand and you can ask your question live. There is no how I say this, there's no, you don't have to turn on your video, but okay. So yeah, we have one question. I am let's get to the I will allow you to speak for a quick second. And yeah, we'll get to the other questions first, okay? Cool. Okay, so I'm gonna allow you to talk in a bit. There's no need to share your screen at all. No, there's no need to show a video, but yeah. Late, please go
Oh,
ahead.
Yeah, Jim.
yeah.
Yeah. Concerning so there, yeah, I would say I've not kind of used it to code when it comes to using Foundry, but I just want to get the concept because I know if I should import some dependency with Foundry, it will still show something like as if there is error. Like, if I import maybe Open Zeppelin or I'm using other dependency, it will show so like as if the path is not correct. So is that the main function of Soldier? So I just want to get what Soldier is really doing. Yeah.
So you're basically sorry, you're basically installing external libraries like OpenJetPlane in your Foundry project, but you get some error messages like dependencies are incorrect. Uh, is that correct?
Yeah, as if the path is not correct. Compile, the code is
Mm,
working, but it's still showing this line that is not the right path, is not the right path. I just want to know maybe
yeah,
if
yeah,
that
yeah.
what Soldier is actually.
Those errors are actually very, very common errors in Foundry. So you can, I think you should check the remapping configs. So basically, there are some configs to map the external libraries, the directories of external libraries in your Foundry project. So I highly suspect that some remapping configs are incorrect in your Foundry project. So you can search, you can Google it by how I can set the remappings in Foundry correctly. Then you can find some answers for your issues, I guess.
Yeah,
Yeah,
thank you.
yeah, thank you.
Sorry, I am muted. Apologies. So Samuel here asks, can we have a practical way of deploying with either Hardhat or Foundry?
What do you mean by exactly? I mean, practical way of deploying with either Hardhat or Foundry.
Uh, yes.
Can you elaborate this?
Yeah. So if you are keen to speak, I think it's better if you ask the question directly. Otherwise, chat is also allowed. We do prefer
Yeah,
it
you,
if you
you
ask because we can interact with you that way. Yes. Samuel, so can you elaborate a bit further as to what you mean by practical way? Give him maybe a few minutes to chat here because if he's typing.
but basically you can deploy uh the contract using Hardhat or Foundry with the basic commands that I mentioned in the slides. Yeah, there is no fancy features for deploying contracts. Yeah, there are any other fancy features for deploying contract.
I
In
hope
production grade, in production grade, we just use the deployment scripts, the basic deployment scripts, for deploying the contracts. Yeah, go ahead, sure.
Yeah, I hope that answers the question. If Samuel hasn't typed anything, hope that answers the question. Do we have any further questions? Is he still here? He is still here. Okay. Any further questions? Probably give it another minute or so for people to type if there's any questions. Yeah.
Yeah, and Eric pointed out very good point. So Hardhat is great if you are building a complete tab and want integration with your JS stack. Yeah, that's one of things that I forgot to mention in this slide. So if you want to build like some monorepo for uh from the contract and your front end and back end applications, so you can basically use JavaScript or TypeScript for all those projects, I mean, integrated projects. So it would be sometimes it is more some developers more prefer to use Hardhat uh, in terms of that point. Yeah, that's very good point.
Yes, exactly. Kudos to our ambassador. He's also Eric here is our ambassador. He's one of our dev
Yeah.
ambassadors. He's here helping out as like sort of a mentor. So if there's any, I think, yeah. So if there are any further questions after we end this workshop, this lesson or whatever, um, please do ask them in Discord. If you're not in a Discord, please do join the Discord. I think everyone here should have come from Discord. I think so. So yeah, if there are no further questions, I think we can end it here. Any further questions, push it to the Discord under Bootcamp General. Eden is also there, so he can also
Yeah.
try not to tag him because he's very busy. But if
No.
anything
Feel free
related to
to
this
tag
lesson,
me.
I will
Yeah.
make sure he gets the message on like our own private chats or whatever. Yeah. So yeah, if there are no further questions, oh yeah, the other thing is, as I mentioned earlier in chat, the slides will be released shortly after this lesson because as I think I'm not sure if Eden mentioned it, we want to make sure you guys pay attention during the thing. And I
Mm.
know that it's recorded, but also keep in mind the 90% attendance rate for the hackathon that we're doing. You have to at least attend 90% of all lessons in order to participate in hackathon. So yeah, if you have any friends that missed this lesson, please do reiterate to them that they should at least be attending more 90% of the live sessions. Yeah. If there are understand any final words, Aiden?
Yeah, thank you for attending to this lesson and thank you for your time. And we have another lesson on this Thursday. So yeah, See
Should they
you on
prepare anything
Thursday.
for this Thursday? Like any.
I think no need to prepare anything, but you might have to check the Hardhat starter and Foundry starter that I mentioned in the slides. Yeah.
Yeah, so as I mentioned, the slides will be shared shortly after this lesson. So keep an eye out on Discord. I'll tag the bootcamp participants tag anyway, so those of you who have joined the Discord should receive it. Yeah. All right. So if there's nothing else, take care, everyone, and yeah, have a good rest of your day. Yep. All right.
Yeah. Have a
Bye.
good day. Yeah. Have a great day. Thank you.